Hi, everyone. This is Rodney Lester, as I was introduced. I'm the Reliability Technical Lead for the AWS Well-Architected program, and the other pillar leads actually report to me. We're going to talk today about the Well-Architected Framework, as well as the Well-Architected Tool that was released at reInvent last year. So the AWS Well-Architected Framework actually consists of three primary pieces of information. We have pillars, which I referred to earlier. We have design principles, and we have questions. The design principles apply overall, as well as having specific design principles per pillar and specific questions per pillar. So before we talk specifically about what's in the pillars and the questions and the design principles, we want to talk a little bit about why you would want to apply the Well-Architected Framework. So the Well-Architected Framework was started approximately 6 years ago as we started to see what our customers were doing when they were deploying things to AWS. And so we built this body of knowledge and started to share it with our customers so that they could basically learn the things that we'd learned by working with our customers over the previous 6 years. So it'll enable you to basically do these things. Build and deploy your systems faster, right? So when you're no longer trying to question what is the right thing to do, you'll be able to make decisions faster and actually deploy things faster. We'll point out very common risks that people take that are actually, most of them are fairly easily mitigated. So we'll tell you and provide information for how to detect those risks and mitigate them. You'll be able to learn all the things that we've learned over the course of the years, as well as making informed decisions. So basically, the Well-Architected Framework is a mechanism for your cloud journey. It allows you to learn the best practices, to measure your workload against that, and more important, to improve your architectures and the way you do things. The pillars of the Well-Architected Framework are operational excellence, security, reliability, performance efficiency, and cost optimization. You'll notice that we have operational excellence as the first pillar. The main reason for that is that there's an operational aspect to the other 4 pillars. I'll give you a good example of how the 3 of the pillars really mix together well. That is that you can actually, through poor operational processes for rotating your security credentials for like usernames and passwords for databases, actually impact the availability of your site. So I talked about the design principles. The design principles are basically tenets for designing your systems for the cloud. There's some general design principles, and there's some pillar-specific design principles. The general design principles are listed here. In classic on-premises environments, you often had a long process where you would try to figure out exactly what your resources were going to need to be for approximately the next 5 years. And so that was actually a very expensive process as far as people power was concerned. With the cloud, you can stop guessing what those things are. Another thing that was very difficult to do before was actually test your systems at production scale. You would have a smaller system for doing things like performance and or load testing, but it wouldn't actually accurately reflect what you had running in production. With the cloud, you can set up that system, run your tests, and then take it down when you're done with it. A third thing is it actually allows you to use automation to do everything. So everything in AWS is an API. You can automate your entire experience, your entire deployments. Everything that you do can be automated. And once you get in the habit of performing automation, this actually makes your experimentation easier to perform as well. Another thing that the cloud enables you to do is evolve your architecture. A lot of times it was very difficult to do things like deploy a message queuing system in order to experiment with it to see if you could actually perform some decoupling of your services. With the cloud, you can actually start using that system fairly easily and not worry about figuring out how to operate that system at scale. And the last two are fairly straightforward. We collect a lot of data in CloudWatch and present it to you, so you can use that data to drive your architecture decisions and discover where you can improve things. And the last thing is we always encourage our customers to constantly conduct game days for operational events to ensure that they know what they're doing when an actual operational event happens. The design principles for operational excellence are listed here. So one of the things that is commonly a problem is your operational procedures end up documented in a notebook someplace, and they quickly get out of date. So one of the things that we encourage our customers to do is actually use a concept known as annotated documentation to actually tie your documentation to the actual tooling and, more importantly, reporting on what your systems are doing. This allows you to perform your operations as code. You've probably heard this through various Agile discussions, but it is also a good principle to make frequent small reversible changes. The reason for the frequent small changes is it actually lessens the risk of every deployment you do. If you ensure that everything that you have deployed is reversible, it also lessens the risk. So if you do a deployment, find out that your business metrics are going in a direction you didn't expect them to, you can always revert your code quite easily. You really want to refine your operations frequently. So if you get in the habit of treating your operations as code and get into that cycle of continuous process improvement, this actually allows you to do that. And the last two are once again tied together to that whole game day concept that I talked about earlier. You want to anticipate failures, perform the testing around it, and basically refine all your operations about what you do when something happens. This allows you to learn from all your operational failures and share them among your teams. The design principles for security are listed here. So in the past, you would often create an eggshell model of security where you had an external network firewall and then everything inside was trusted. So one of the things that the cloud enables you to do is apply security at all your layers, and more importantly, actually collect metrics and tracing on every layer that you have. So the foundation for all security is a strong identity service. So the cloud has not only an identity service to help you govern access to items and resources within the cloud, but actually integrate with your on-premise or deployed within AWS identity system in order to grant minimal least privileged access to those cloud services. We make it really easy to protect the data in transit and at rest. It's basically checkbox encryption on all the services. You'll hear me preach automation, automation, automation. One of the primary changes often to an organization coming into the cloud is teaching their security teams how to embrace automation instead of just simply manage tools. And the last one, preparing for security events, ties back to this game day concept I talked about earlier. The design principles for reliability are you can test your recovery procedures. So once again, it was very difficult in an on-premises environment to simulate failures and then try to see if your test procedures actually still worked. In AWS, you can actually run these tests constantly. As a matter of fact, I'd encourage them to be part of your normal integration testing. More importantly, you can actually automatically recover from failure. We often talk about designing for failure in the cloud, and that's not really the fact that things fail, because things fail everywhere. It's that you can actually minimize your time to recovery instead of worrying about the mean time between failures. So you really want to automate recovery from your failures to recover faster. The next two are kind of tied to the principle that I gave at the beginning, which is to stop guessing capacity. So you can actually elastically expand your capacity, and more importantly, you can contract it when you no longer have the requests, so that you can not only minimize cost, but actually effectively manage your capacity. And one of the things that allows you to do that is to scale horizontally instead of vertically. So create more horizontal instances that can respond to it as opposed to trying to scale up and get larger boxes. And once again, I talked about automation. You really want to manage all your change through automation. For performance efficiency, some of the things you can do is actually get availability to these advanced technologies. I talked about it earlier with message queuing systems, but the cloud offers things like streaming services, document databases, NoSQL databases, relational databases, as well as things as far as transcoding services, live media services. There's a lot of options of things that you can actually get access to and try fairly easily. You can get a global infrastructure quite easily using the cloud. Not only do we have a content delivery network, but we actually have data centers around the globe. So if you were planning on an international expansion, a lot of times you had to go out and actually find people who could find space for you to actually deploy applications, which was a very long process. With AWS, once you have an account, you can actually deploy things around the globe in minutes. You can get a lot of performance efficiency using serverless architectures. If you have things that are very transient, you can actually use serverless architectures to respond at the time that you need to and then effectively be non-existent at all other times. So this enables you to experiment more often overall. The last design principle is mechanical sympathy. You've probably heard of using things like databases as queues. So you put something on a database and then somebody else queries it and processes it. This is known as a design anti-pattern. But a lot of people use that because they couldn't implement a queuing system very fast, so they just used what they had. One of the things that you're able to do with the cloud is you're actually able to use services for what they're purpose-built for. These are the design principles for cost optimization. So adopting a consumption model allows you to actually pay as you go, and you'll pay for the services that you use and not for those that you don't. This kind of goes hand in hand with the elastic model I talked about earlier. The real way to save money is by not paying for things when you're not using them. So we provide a lot of instrumentation and availability for you to actually be able to measure this to understand whether or not you're actually overpaying for your infrastructure. So this allows you to stop spending money on your data center operations, right? You don't have to spend money on the security guards, the first level ops people, even for the buildings themselves, rent, power, cooling, etc. The cloud enables you to do things like tagging, cost allocation tagging, so you can analyze and attribute your expenditure. A lot of times on premises, the entire data center is one big cost center, and it's very difficult to track who's spending what money on what within that data center. With the cloud, you can actually get reports that attribute exactly what applications are using which services and how much they're spending on it. And last is this concept of using managed services to reduce your total cost of ownership. If you have ever spent any time managing large infrastructure applications, you know that often just the management of the underlying operating systems and/or software itself can be a fairly large job. So if you use things like Amazon RDS, our relational database service, Amazon Message Queue, which is a MQ-based service, you actually get the management of patching and operating the underlying infrastructure for you for free, and you can concentrate on the hard part, which is your business problems. So from here, I'm going to talk about the AWS Well-Architected Tool. So the tool was released at reInvent last year, and it provides you the ability to go through our Well-Architected Framework and provide answers to this and get reports. I will talk about this in detail. So the features that are listed here are what you can do within the tool. The primary concept for conducting a well-architected review is something called a workload. A workload is a collection of services and data that you use to perform some function. It can be fairly arbitrary, but usually it's pretty well defined within most companies. So when you define a workload, you define the attributes about it, and then you can perform a review on it. You can change the priorities of the pillars. The 5 pillars that we listed are the default priority: operations first, security second, reliability third, performance, and cost. But depending on what you're trying to improve, you may want to change that priority. So you can do that within the tool. Then as you go through the review, as you ask every question, there's actually a bunch of information that you can learn information about what we mean when we ask that question, what we mean when we give you a best practice. And so you can go off and learn about what best practices are, and we'll give you a bunch of helpful information about how to figure that out. Once you've filled out the review, you can generate an improvement plan. So the improvement plan is presented within the website itself, but you can also generate a PDF report if you wish to share it with someone. Once you've got a list of workloads, you actually have a dashboard that you can go through and see what the status of your workloads are. And last is a feature that we call milestoning. So when we talk about conducting reviews, if it's a brand new application, typically we encourage you to review it 3 times before you actually deploy it. So as soon as you have a design, it's good to walk through the Well-Architected Framework to discover what you may have forgotten or may have not thought of. Once you've implemented it and you're getting ready to perform all your testing, all your final testing, load testing, etc., we'd recommend you look again to see if there's something that you perhaps left off of your implementation plan that may be regarded as something critical. And then prior to launch, you could actually use the Well-Architected Framework as part of your operational readiness review to see if you're actually ready to deploy this to production. And then we encourage you afterwards to actually continuously review your systems, because the way it generally works at most companies is you'll get turnover and people switching among applications, and some things that are learned by certain people will not be known by the new people that come in. This enables you to have some continuity in how you approach things as you go, and also make sure you don't accidentally revert at some point. So what are some of the customer use cases? Why would you actually want to use the tool? So there's a lot of people who are coming fresh to the cloud, and they just really don't know what they don't know. So if they want to learn the basics of architecting for the cloud, walking through a well-architected review will help that. This will prevent them from being constrained by their on-premises assumptions. They'll actually be able to learn or unlearn things that they may thought were dearly held truths that may not work the same way in the cloud. Often people log into the AWS console when they're first starting, and they see the list of services and they don't know where to start. So one of the things the Well-Architected Framework will give you the ability to do is basically give you some of the base services for how you want to implement something and give you some ideas of where you want to start. And if you want to know if you've done something wrong, once again, the Well-Architected Framework will give you a list of items, basically, if there's critical items identified, things that need improvement, or things that meet our well-architected practices. So basically, it allows you to learn the AWS best practices, transition to cloud native, identify improvements. Once you have those, you actually will be informing your future architectures. So as you start establishing this knowledge base among your developers, they will be able to use this as a basis for further developments. The signposting of resources and services basically refers to the services that we think will help you to accomplish some of the things within the Well-Architected Framework. So that answers the question of where do you want to start. Often there's a governance piece to any system. It can be related to regulation, or it can be just internal governance, or it can just be things that you want to make sure that your teams have adhering to your own best practices. So things like, are you ready to go to production? Are you following existing best practices? How do you compare and make sure that you're measuring every workload consistently? And how do you know what risks you have, and how can you see if you're actually improving against these, or if you're getting worse? So this tool gives you the ability across the 5 pillars to conduct the review, which gives you that consistency. And when we talked about the reporting earlier, it'll give you the status of all your current workloads, as well as in each workload you click down and find out what you should be improving upon, and you can study trends and see if your teams and systems are actually improving. For portfolio management, in very large companies, but it can be even fairly small companies, there's times where you really, after 10, 12 years, you may not know all the workloads that you have. So this will give you an ability to actually have a place where you've documented all your workloads. You'll be able to figure out what decisions you made in each. You'll know what risks you have. I talked about the risk evaluation over time earlier, but this gives you an ability to actually figure out the general risks that you keep making, and maybe where you should invest in training and or knowledge in order to make sure that you don't make those mistakes over time. Also, you can take a look and see if there's some greater trend that you want to correct. And last, it will give you an idea of where you actually want to build something to perhaps enforce certain best practices or other mechanisms. So with this, we're going to go through a bit of the getting started video. The complete video actually covers some of the information we've had. But at this point, we're going to show a short video.
Welcome to the AWS Well-Architected Tool. The Well-Architected Tool provides a consistent approach for reviewing your architecture against AWS best practices and gives advice on how to architect in the cloud. The subject of a review is a workload. This is a collection of AWS resources and code that delivers business value. A workload could be a subset of resources in an account, or a workload could cover a subset of resources across multiple accounts. A small business may have a few workloads, while a large enterprise may have thousands. Examples of workloads are an e-commerce website, mobile application backend, or a corporate HR system. At the end of the review, the Well-Architected Tool identifies the issues in your workload, prioritized by the level of risk. The Well-Architected Tool also provides an improvement plan to address issues. To mark major changes or releases, you can create milestones. Milestones keep a record of your workload at a point in time, and you should use multiple milestones to see how the workload changes over time. The dashboard view allows you to see a summary of issues across all of the workloads in your portfolio. When you are ready to review your workload, click Define Workload. Enter your workload details and click the Define Workload button. The Workload Overview screen displays, and you can now review your workload by clicking Start Review. This starts the question and answer experience. You can navigate through each pillar and question on the left-hand side of the screen. Each question is displayed at the top of the screen, with additional context, and the answer choices are listed below it. You should select the best practices that you are following for your workload. If a question is not relevant to your workload at this time, you can mark the question as question does not apply to this workload. This will exclude the question from this review. Help for this question is on the right-hand side of the screen. There is a video explaining the question in more detail, and you can also access resources that help with this question. For help on an answer, click the info link next to the answer. The Well-Architected Tool also provides an inline glossary to explain technical or AWS-specific terms. To see a quick definition, hover over a term, or click it to see the full definition. We include a full definition of the term and links to further information, such as service documentation. When you are ready to answer the next question, click Next. This saves your response and moves to the next question. For the purposes of this video, all of the questions for each pillar have now been answered, and a Review Complete message is displayed. The Well-Architected tool has an improvement plan, which provides AWS best practice advice for every question. Click a question within a pillar, and this takes you to the steps to reduce risk for this question. You can see the full improvement plan by clicking on a step. If you need help implementing the improvement plan, the Well-Architected tool recommends AWS Partner Network members who can help you, as well as AWS Marketplace solutions that you can use. The improvement plan is ordered by pillar priority. You can either use the default order or reorder the pillars based on your priorities. From the Workload screen, click the Improvement Plan tab, click Edit under Improvement Plan Configuration, and arrange the pillars in order of priority for this workload. Then click Save. You will see that the pillar priority has changed, and the improvement items below are listed in that same order. You can access the improvement plan steps here as well. We recommend saving a milestone after you answer all of the questions, or when significant changes are made to your workload. In this example, we create a milestone named version 1.0. This creates a read-only record of the review at this point in time. You can create multiple milestones as your architecture evolves and see what the review looked like for any previous milestones. The dashboard shows you a summary of the risk ratings for all of your workloads. It also shows your completed workloads and milestones over time.
Thinking cloud natively. This will change the way that you think as far as the constraints that you are used to having versus what you can do within the cloud. This provides a consistent approach to reviewing all your architectures. So once you've applied this consistent approach, you'll actually be able to share knowledge between your teams as well as identify where some of the critical needs are that you have. You'll be able to understand the potential impact of all the decisions you've made. So we evaluate them based upon high risk, medium risk, and low risk. So the high risk items we really would encourage you to address as soon as possible. So this gives you the visibility onto those risks. And that's one of the key things that you often do not have. So it behooves you to be honest with yourself when you're conducting a review of your own architecture. At this point, we're going to go to a customer testimonial, Cox Automotive, who has used the Well-Architected Framework to improve several of their workloads.
Hey there, and welcome to Are You Well Architected? I'm your host, Rudy, and today we're talking about the automotive industry. We've got Cox Automotive here. Kevin and Jean, welcome to the stage. And you know what, let's start with you, Jean. What does Cox Automotive do?
So our mission is to transform the way the world buys, sells, and uses vehicles. We're a company of 30 different brands. Autotrader.com and Kelley Blue Book are some of the more popular brands. And we've got hundreds of engineering teams that are working across the globe to create exceptional solutions for our dealer customers, manufacturers, and end consumers.
And it sounds like you guys have done several well-architected reviews. Last I heard was about 20 or so. So you know what, let's switch back to you, Kevin, and say, what's this solution that I've been hearing about, this real-time bidding solution, and how did the Well-Architected Framework help you realize it?
Sure, so the real-time bidding system is an integration that we have with the ad exchanges to place advertisements for our clients on various web properties. It's a very high traffic system. On-prem, it was located in 2 different data centers, East Coast and West Coast. And we recently went through an effort to migrate it to 2 AWS regions. It took us about a quarter of work to get from 1 data center to 1 AWS region. And then a few days after that, we had the other region live using infrastructure as code to facilitate that. Once we got that done, we knew we had taken a lot of the legacy decisions with us as we moved out of the data center. And so the well-architected framework allowed us to focus on the things that we wanted to do to get to a more cloud-native architecture.
Okay, so it's kind of a stifled migration where you start small, move it across, and then keep going. So as part of that migration itself, did you go into any particular pillars and from there kind of realize even more gains?
We did. We focused on the performance efficiency pillar. And one of the decisions we had made early on was that we were going to lift and shift. We weren't going to take an approach of using auto-scaling groups, for example, or various other scalability aspects of it. And that's something that came out really well in the well-architected review. So now we're looking at going back and introducing auto-scaling into the application. We want to be able to utilize the resources as efficiently as possible, and also decrease the likelihood of failure and be able to spread the compute across multiple availability zones, multiple regions.
Okay, and as with any system, you kind of want to make sure it's very secure.
Yes.
So you utilize the security pillar too, from what I've heard. Can you kind of elaborate on that?
We did, and one of the things that's interesting with Cox Automotive is the way that we're using AWS accounts. We have hundreds, close to 1,000 AWS accounts, and to make those secure on an account-by-account basis would be terrifying from a security perspective. So we've put a lot of tooling in place around that. We've built tooling that gives federated access to all of our internal developers, so we don't have developers that have long-lived keys. So we can just, from the beginning, knock that off. We don't maintain any of the root account keys. So we try and lock these accounts down as much as possible. We provide CLI, web-based, and desktop tooling for developers to get in and do the work they need to within the account to execute infrastructure as code to do their deployments. And that tooling is consistent across all those accounts. So one of the nice things when we go through the well-architected review, we're able to quickly go through the security pillar because most of that is just part of the landing zone that we've defined for all of those accounts.
Okay, cool. And if we switch back to Gene over here, so with regards to all the reviews that you've done and kind of across your org, how has this benefited interactions with teams? Are you guys using data-driven let's say a paradigm nowadays?
Yeah, I was going to say there's a couple of different benefits. One is certainly the data-driven approach. So one of our principles is to use data to drive the evolution of our architectures. Another is the engagement that we've had with our teams, and another is an opportunity to bring visibility to the great work that our teams are doing, and also to have them to showcase some opportunities and get in front of the business and say, here's opportunities for us to make improvements either around modernization or simplification, reducing technical debt, things like that.
You can get started in a few ways if you don't want to just dig into the tool. We actually have white papers around not only the well-architected framework, but we have pillar-specific white papers for each pillar, as well as 3 AWS well-architected lenses. Those lenses are serverless, HPC, and IoT. The AWS Well-Architected Framework also has a free online training that you can link to off of our main page, which is linked there, which is aws.amazon.com/well-architected. And if you need more information on the tool itself, I absolutely encourage you to go to the AWS Well-Architected Tool product page, which we link to not only in the Q&A, but here on the presentation. You can read about what the product has to offer, and there's a link right there in yellow to get started with the AWS Well-Architected Tool. And with that, I'm going to hand it back to the moderator